Om Swastiastu. Thank you for the opportunity and allow me to start the presentation. We're from Student Group Discussion of B9 and here will be represent our student project titled Antiviral Agent for Management of COVID-19. Here are the group member of B9 Student Group Discussion. And on this presentation will be divided into 3 chapters. The first one is introduction, second is discussion, and the third or the lastly is conclusion. Firstly, we'll start from chapter 1.
Hello everyone, my name is Gede Vivekananda Rusdi with student ID number 22025111190 and I'm a member of the group B9. In this opportunity, I would like to present about the background of our student project, which entitled Antiviral Agent for Management of COVID-19. So let's start with the background. In December 2019, a new coronavirus now called SARS-CoV-2 caused a series of acute atypical respiratory illness in Wuhan, Hubei province, China. The disease caused by this virus is called COVID-19. The virus is transmissible between humans and has caused a global pandemic. Since February 20, 2020, 75,995 cases have been confirmed, including thousands of fatalities on the Chinese mainland alone. This virus journey became a local epidemic in food market in December 2019, and during this early phase, close contact transmission from person to person had taken place. On January 13, Thailand reported the first case outside of China, and 5 countries had reported 60,329 cases as of February 12, 471 times the initial figure. After the SARS-CoV-2 outbreak in China, it has expanded globally. The United States has the most reported COVID-19 patients as of early April 2020, followed by Spain, Italy, Germany, France, and China. As of August 11, 2021, 4.3 million SARS-CoV-2 deaths have been documented globally all around the world. Following SARS-CoV-2 infection, some infected people may remain asymptomatic or only exhibit mild upper respiratory symptoms, while others may develop pneumonia and severe acute respiratory distress syndrome. Based on the pathological features and different clinical stage of COVID-19, clinical researchers are using and testing a variety of possible treatment in the early stage of SARS-CoV-2 infection, such as the role of antiviral agents for preventing the progression of the disease. Based on this premise, this student project aims to discuss the role of antiviral agents for treating patients with COVID-19 infection and its advantage and challenge. That's all from me. Thank you.
Hello, my name is Putri Cahyani with my 3-digit last ID number being 185. So I will be introducing the objectives. So the first one is to know the definition of antiviral agent, and the second one is to know the types of antiviral agent, and the third one is to know the mechanism of work of antiviral agent, and the fourth one is to know the efficacy and safety rates of antivirus for treating COVID-19, and the fifth one, being the last one, is to know the challenges and advantages of antiviral agent treatment. And then the next one is the benefit. So the first benefit is how to improve COVID-19 patients' outcome, increase people's awareness against available antiviral agents in treating COVID-19, increase the number of possible treatments for COVID-19 patients, and the last one being to help doctors to decide whether to give antiviral agents to COVID-19 patients or not. So that's all that I can give. Thank you.
Hi, so my name is Tjokorda Putri Mahadewi, with the last 3-digit number is 189. In here, I will explain about the definitions of antiviral agents. So antiviral agents is a drugs that support the body's defense against specific viruses that can spread disease. And antiviral drugs are also preventive, protecting from getting viral infections or spreading virus to others. And there's 5 basic steps of viral replication cycle. The first one is the virus attached to and enters the host cell. The second one is the virus is uncoated. The third one is the host cell synthesize new viral components as instructed by the virus DNA. The fourth one, the components are assembled into new virus. And the last one is the virus is released from the host cell. That's all from me, and my friends will continue about the next topic. Thank you.
First of all, thank you for the opportunity given to me. My name is Putu with last 3 digits of student ID 201. And now I'll explain about type of antiviral agent remdesivir. Remdesivir, or RDV, formerly known as GS5734, is an adenosine analog monophosphoramidate product developed in response to the 2014 Ebola outbreak in West Africa. Remdesivir is an antiviral drug with properties that inhibit viral replications of SARS-CoV-2. RDV exhibits broad-spectrum antiviral activity against RNA virus, and previous studies using RDRP or RNA-dependent RNA polymerase of Ebola virus or EBV and Middle East Respiratory Syndrome coronavirus or MERS-CoV. A retardation chain is shown that disrupts the possible mechanism of remdesivir. RDV binds to RDRP and functions as an RNA chain terminator. RDV is very demanding of viral polymerase and is therefore unlikely to cause toxicity in humans. Furthermore, it has been shown to have a broad therapeutic index in human airway epithelial cell models. The drug also has a high genetic barrier to resistance to coronavirus and extended intracellular half-life, allowing once daily dosing. That's all my explanation about remdesivir. Thank you.
Hello everyone, my name is Pradnyana Jayawardana with my last 3-digit ID number 193, and today I will present the types of antiviral agents molnupiravir. Molnupiravir is an isopropyl ester product which is cleaved in plasma by host esterases to an activate nucleoside analog BDN4 hydroxycytidine. SARS-CoV and other viruses can replicate when molnupiravir is used. It decreases SARS-CoV-2 RNA in patients, prevents SARS-CoV-2 transmission in ferrets, and prevents SARS-CoV-2 replication in human lung tissue. Molnupiravir is an approved medication that can be used orally, as opposed to infusion-based medications like remdesivir. For safety, tolerability, and pharmacokinetics, molnupiravir has undergone phase 1 trials. Phase 2 and 3 investigations are now in progress. So, it can be concluded that molnupiravir is an orally accessible medication that can prevent SARS-CoV-2 replication by causing deadly mutagenesis and evading viral proofreading mechanisms. Molnupiravir is shown to have strong antiviral effectiveness against SARS-CoV-2 in both in vitro and in vivo investigations. Clinical studies findings demonstrate this drug's good bioavailability, safety, and tolerability. Patients with mild or moderate COVID-19 were found to benefit significantly from molnupiravir's effectiveness. In individuals who are not hospitalized and have mild to moderate COVID-19, it may lower their risk of hospital admission or mortality. However, molnupiravir's genotoxicity is a cause for worry. Thus, a thorough analysis of clinical studies and a long-term safety assessment of molnupiravir are required. That's it about antiviral molnupiravir. Thank you.
Hello, doctor. My name is Michael Jonathan Raya from last 3-digit name 182. In today's chance, I'm going to explain about types of antiviral agent called lopinavir. So about lopinavir, it is a drug that has been studied in these past few years, especially since the COVID-19 outbreak. The scientists hope to find a drug that could effectively kill against COVID-19, and lopinavir is one of their research options. And actually, lopinavir is a drug that commonly used by the people infected by HIV. It could reduce the amount of HIV in humans' body, so it could prevent the people to get AIDS and prevents the transmission to another people. And there are several ways for antiviral agent to inhibit virus replication process, such as protease inhibitor, and lopinavir is one of it. Lopinavir is usually combined with ritonavir, a similar drug that could maintain the amount of lopinavir in humans' blood. And I've also done some several research. The first one is about lopinavir in SARS treatment. So the scientist wants to know whether lopinavir is effective against the SARS or not. And the result is indeed shows that lopinavir is effective against the SARS. And the second research, it's about efficacy and safety of lopinavir in COVID-19 treatment. The scientists also want to know, because of its prior research in SARS treatment, Lopinavir is indeed effective, and COVID-19 has the similarities with SARS, but unfortunately, the result shows that lopinavir is not effective against COVID-19 infections. So in conclusion, lopinavir is still researched by the scientists and developed further. And another antiviral agent are also still researched in hope to find a drug that could effectively against COVID-19 infections. And that's all from me. Thank you.
Good morning, doctor and all my friends. Let me introduce myself. My name is Nilo Putu Iswari, Ardha Dharani, and my last ID number is 183. And now I will present you about favipiravir, which is one of antiviral agent. Favipiravir was approved in Japan as a drug to treat new outbreaks or re-emerging influenza viruses after an infection in 2014 because other antiviral influenza drugs were less effective at treating the disease. Favipiravir is a type of antiviral that has the potential for therapy in COVID-19 patients. The research conducted at a hospital in the city of Denpasar, Bali, starting from August 2020 to January 2021 and provided results related to effectiveness of favipiravir in the treatment of COVID-19 patients. There were a total of 192 patients, with 96 of them being treated with the favipiravir group and the other 96 were in the non-favipiravir group. And the result is show that favipiravir is effective to be administered to patients with COVID-19. However, until now, favipiravir has not been officially declared effective and capable of being an antiviral for COVID-19 patients. Further research is needed to find out whether favipiravir is really capable of being an antiviral for COVID-19. Thank you.
Good morning, doctor. My name is Joseph Nga Xhi Wei with the name of 250. Today, I'll be describing about Paxlovid. So, Paxlovid is a drug developed by Pfizer and is made up of two different generic medications, namely nirmatrelvir and ritonavir. And it's also supported by the EAU of the FDA due to high effectiveness in vaccinated people. Paxlovid is used to treat mild to moderate COVID-19 in adults and in children, and it can also reduce the risk of hospitalization and death. Thank you.
Hello, my name is Anak, Agung, Sagung, Rania, Kesuma, and the last three digits of my student ID number is 181. I will explain about each mechanism of the antiviral agent mentioned before. Number 1, remdesivir. After entry to the host cell enzymes converts remdesivir to its active form. RDVTP attached to RDRP enzyme complex, then will compete with RDRP, then synthesis of viral RNA is inhibited. Number 2, molnupiravir. Esterase converts molnupiravir to its active form. This active form will disturb viral genome transcription while also helping escape proofreading enzymes. Then mutation occurs. Error catastrophe occurs because the products from transcription and translation contain mutagenic base pairs. This mechanism reduces viral replication. Number 3, lopinavir. When translation occurs, lopinavir mediates excision of 3-CLP and other non-structural proteins responsible for viral replication. This mechanism of action will inhibit synthesis of viral protein. Number 4, favipiravir. Cell enzyme convert favipiravir to its active form. This active form is recognized as a substrate by RDRP and also inhibits viral RNA polymerase activity. This means viral RNA replication is also inhibited. Number 5, Paxlovid. Paxlovid will block coronavirus 3-CLP activity, which is important for viral replication. Paxlovid also inhibits C4503A4 that is responsible for the metabolism of molecules, resulting in the slow metabolism of PF07321332, aka nirmatrelvir, so that it will remain active longer in patient's body. This can help reduce mortality and hospitalization rates of COVID-19 patients. I think that's all I can explain about the mechanism of antiviral agent for COVID-19. Thank you.
Hello everyone, my name is Ananta Wismaya with the last three-digit number of 198. Now I'm going to tell about the effectiveness of antiviral therapy. COVID-19 have become a major threat for global health, and hundreds of clinical studies and related drugs trials have been reported. Many studies have compared between many different drugs such as lopinavir, favipiravir, molnupiravir, remdesivir, and many more. Given the current pandemic and shortages of drugs to treat COVID-19, we believe expedited clinical trials should be conducted. However, this does not mean allowing low-quality clinical research. Scientists around the world are currently tirelessly to develop therapies against COVID-19. To date, several drugs have shown promising results. Among the antiviral trials reviewed, remdesivir demonstrated clinical significant improvement in several studies. This is evidenced by showing a clinical improvement of 68% in a case series of 53 patients with severe COVID-19. Remdesivir is currently the most potential antiviral drug to treat COVID-19. The efficacy and safety of other antiviral treatments are controversial and more high-quality clinical trials are needed. That's all from me. Next.
Hello, my name is Nyoman Gede Wiraguna dari Paramartha and my last three-digit number is 180. Now I'm going to explain about the safety of antiviral therapy. In general, no studies have investigated the efficacy of antiviral therapy alone in the treatment of COVID-19, and all available articles report the use of antibiotics, immunoglobulins, interferons, glucocorticoids, antifungals, antiparasitics, and etc. Other treatments are being used in research. Therefore, the report presented cannot be attributed solely to antiviral drugs. Because there aren't enough well-designed prospective trials or observational studies, there is currently insufficient evidence to make any recommendations regarding the efficacy and safety of antiviral therapy for coronavirus. However, it is evident that the current body of evidence is significantly biased in favor of ribavirin, which has not demonstrated solid proof of benefit and may result in detrimental adverse events. Therefore, future studies may think about concentrating on other antiviral therapy candidates. So that's it from my explanation about the safety of antiviral therapy. I hope you understand and thank you.
Hello everyone, my name is Amelia Sasikirana Dewi with last three digit 207. Today I will explain about progress and challenge of antiviral agent treatment. The first one is current status. So antivirals have been widely used to treat chronic virus infection like HIV and hepatitis C virus. Their use to treat acute viral infection has been constrained up until now due to the threat of efficient antiviral therapies and a condensed window of opportunities to administer treatment and enhance patient outcome. We now have multiple efficient antiviral medication to treat COVID-19 thanks to excessive time and financial commitment, as well as unprecedented interaction between researchers, doctors, and biopharmaceutical sectors. For instance, recent fluoxamine clinical trial results revealed a therapeutic advantage in slowing disease progression through a yet unidentified mechanism. Additionally, we must look beyond COVID-19 and learn from this pandemic in order to better prepare ourselves in inevitable future pandemics. That's all from me. Thank you.
Greetings, my name is Aryanda Maitri Anjasrini with the three last digit of student ID number 188. Here I will represent the challenges of antiviral agent treatment. Over time, viral infections saw their significant impact and responsible for millions of deaths in different countries, including current pandemic of COVID-19. These are some elements that make it challenging to develop antiviral agent treatment, especially for COVID-19. The first one is efficiency and effectiveness to counter viral infection. As we know, virus as metaorganism will continue to evolve in order to sustain its existence. For coronavirus itself, as a rhinovirus, they possess the ability and morphology that allow them to do an ultra-fast mutation, for instance for the spike protein, resulting higher transmission rate and for the new strain if then compared with the original ones. And the second one is waning immunity, which is condition when our body protection against infection declines as antibody levels decrease after the last dose. And the last one is growing skepticism and lacking trust on vaccination safety and effectiveness. As we know, growing causes and skepticism over vaccination is what our society is facing right now. Living in this globalization era where social media becomes news sources, making individuals vulnerable to trust fake news or hoaxes.
Hello, my name is Putu Cahyani with the last three digits of my ID number being 185. So I will be giving the conclusion and suggestions that we have made as a group. So for the conclusion, antiviral agents are medications used to assist the body's defenses against particular viruses that may spread diseases. They are drugs that have been approved by the FDA to be used to treat or prevent viral infections. The fact that coronavirus are categorized as an RNA virus, which have the capacity to mutate at an extremely quickly rate and severe harmful effects, makes developing treatments against them as one of the most challenging outcomes. There are 5 main types of antiviral agents used to treating COVID-19, and these are remdesivir, molnupiravir, lopinavir, favipiravir, and paxlovid. The mechanism of antiviral agents is different for each of the types. For the mechanisms of remdesivir, it works by inhibiting the molecular mechanism of viral RNA synthesis in the target cells. And for molnupiravir, it works by targeting the enzymes used by SARS-CoV-2 for transcription and replication of its viral RNA genome. And for lopinavir, it acts as a drug that targets the virus protease, which is responsible for breaking down proteins into shorter polypeptides or amino acids. And then there's favipiravir, which is a drug that has shown potent antiviral activity against positive strand and segmented negative strand RNA viruses. And these drugs have undergone several clinical studies for its effectiveness and safety to be assessed. However, based on the studies conducted, there are several challenges that were occurring and leading towards multiple limitations. So, for example, for the limitation include the use of small sample size, the loss of follow-up for several samples, and the zero involvement of placebo group as a control group. As of now, remdesivir has been authorized for use in patients with severe COVID-19 according to the Food and Drug Administration, and is demonstrated a clinical improvement of 68% in a case series of 53 individuals with severe COVID-19. And for suggestions, COVID-19 case continues to emerge since the year 2019. Several drugs, including drugs for parasites, have been prescribed to treat patients with COVID-19. For a drug to get its license and to be commercialized, there are 3 stages of clinical trials that must be passed, which altogether require more than 15 years to conduct. The long period of the time needed to develop a drug, and due to this long period of time, it is nearly hard to keep a positive correlation between the rapid increase in COVID-19 cases and the slow development of antiviral drugs to treat COVID-19. In other words, the growth of COVID-19 across the world is much more rapid compared to the time needed to fully conduct clinical trials towards a drug for it to be distributed to the world's population. In Indonesia, there's a total of 6.7 billion COVID-19 cases with roughly 160,000 deaths. Based on this, it is understandable why several kinds of drugs have been used to treat COVID-19 in the medical world. We believe that the antiviral drugs used to treat COVID-19 have undergone some steps of the 3-stage clinical trials needed to see its effectiveness in treating COVID-19 patients. As of December 2020, the only Food and Drug Administration or FDA approved drug to treat COVID-19 is remdesivir, as I mentioned before. This suggests that for future COVID-19 cases, the antiviral drug should be used to suppress the spread of COVID-19, as its safety and efficacy has been proved. Furthermore, the urgent need of prescribing approved drugs to treat COVID-19 is essential to reduce the mortality rate of COVID-19 itself. So that's all that I can say for the conclusion and suggestions. Thank you.
That's all from our presentation. We apologize if there are any mistaken words or wrong things that we do, and we'll close this presentation with Om Santi 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 Om. Thank you.